Okay, determine the range of each function using the domain. The domain is your x. So we have 1, 2, 3, 4, 5 x's. We're going to get 5 y's. This is how you would do this. We would start off by getting f of negative 3. So notice I replace the x with a negative 3. I'm going to get f to the negative 1. I'm going to get f to the 0. I'm going to get the function of 2. And I'm going to get the function of 4. So notice I'm going to have 5 different equations. Equal, negative, and I'm going to replace x with these numbers. So negative 3 plus 2 squared minus 3. Negative 1 plus 2 squared minus 3. 0 plus 2 squared minus 3. And 2 plus 2 squared minus 3. And 4 plus 2 squared minus 3. Now then, you have a calculator. You could also graph this and trace to these and get your range. I'm going to do this in my brain. Negative 3 plus 2 is a negative 1. Negative 1 times negative 1 is a positive 1, but you're going to have a negative here. So negative 1 minus 3 would be a negative 4. Negative 1 plus 2 is 1. 1 squared is 1, but it's negative. So negative 1 minus 3 would be negative 4. 0 plus 2 is 2. 2 squared is 4, but it's negative. So negative 4 minus 3 would be a negative 7. 2 plus 2 is 4. 4 squared is 16, but it's a negative. So negative 16 minus 3 is a negative 19. Remember, this graph would open down, so these numbers are going to get smaller. Also, our vertex would be somewhere between these two numbers, wouldn't it? It would be negative. Actually, it would be negative. It would be at the 2, wouldn't it? It would be negative 2, negative 3 would be our vertex, wouldn't it? And then finally, 4 plus 2 is 6. 6 to the second is 36. Negative 36 minus 3 is negative 39. So our range would be these numbers. Just do the math. You could type this straight into the calculator to get these numbers and eliminate the ones that aren't right. Now then, I'm going to do the same thing for this one. I'm going to write down f of negative 3, f of negative 1, f of 0, f of 2, and f of 4. Also, one thing right here, this f of 0, the 0 comma negative 7 would be our y-intercept, wouldn't it? If you input 0, your answer would be the y-intercept, wouldn't it? So negative 7 would be our y-intercept. Let's go over here to this one. On this one right here, I'm going to replace the x with a negative 3 squared plus 4. Then 2 parentheses negative 1 minus 1 squared plus 4. 2 parentheses 0 minus 1 squared plus 4. 2 parentheses 2 minus 1 squared plus 4. And 2 parentheses 4 minus 1 squared plus 4. Now then, I'm going to get my answers. So all I did is take these numbers, replace them in x. I'm going to put this number in for x. Notice that negative 3, negative 1, 0, 2, 4. I made 1, 2, 3, 4, 5 equations, aren't I? And I'm going to get 5 answers. Negative 3 minus 1 is a negative 4. Negative 4 squared is 16. 16 times 2 is 32. And 32 plus 4 is a 36. That's basically what the calculator is doing. Negative 1 minus 1 is a negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 plus 4 is 12. Okay, 0 minus 1 is 1, or negative 1. Negative 1 squared. Negative 1 squared would be 1. 1 times 2 is 2. 2 plus 4 is 6. And then right here, 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 times 4 is 6. And then right here, 4 minus 1 is 3. 3 squared is 9. 9 times 2 is 18. 18 plus 4 is 22. Notice that our vertex would be 1, 4, wouldn't it? And what happens between the 0 and the 2 is where it starts going. This graph would not cross the x-axis, okay? It's going to open up. It's going to be the vertex is at 1, 4, and it's going to open up, and it won't cross the x-axis. And our This point right here is important. 0, 6 would be our y-intercept, wouldn't it?